Subcommittee will come to order. We meet today to discuss a critical part of transportation infrastructure, the Global Positioning System, commonly referred to as GPS. So I'd thank the witnesses for their participation in today's hearing and would like to say a special welcome to Deputy Secretary Mr. Portkari and Mr. Galati, our witnesses from the United Nations International Civil Aviation Organization, a very important framework for our global aviation industry. Your participation in today's hearing speaks to the importance of this issue not only here but around the globe. For this committee, for this subcommittee, aviation safety is the top priority. According to the Department of Transportation, the Global Positioning System has served as a critical component of aviation safety improvements that the aviation community has embraced. Moreover, GPS is critical to the safety and efficiency improvements planned as part of NextGen that we're in the process of rolling out here in this country and other countries as well. Our aviation infrastructure and efforts to update it with the Department of Transportation's NextGen program are a platform for growth in the U.S. economy. NextGen is also a catalyst for job creation within the aviation industry. It's important for government to avoid constraining that growth by limiting the efficiency gains and job creation achieved by NextGen, which is reliant on GPS. As important as GPS is to transportation safety and efficiency, its signal strength is very weak. Therefore, GPS is susceptible to interference by other transmissions, even if those other transmissions are constrained within their own spectrum allocation. Over the past year or so, the subcommittee has watched with interest the developments of issues related to radio spectrum within the L band. As the Federal Communications Commission deliberates the issues before it, we recognize the potential impacts on the transportation community, and hence today's hearing. However, out of fairness to the parties involved in the FCC proceedings, I'd ask the witnesses to focus their comments today on the question at hand regarding the importance of GPS as an element of transportation infrastructure and the public policy considerations of the transportation community to protect that infrastructure. Today's hearings serve as an opportunity to hear ideas for the best way forward given what we've learned about GPS. Where there are good engineers, there may be a variety of solutions, and it would be helpful for technologies to coexist because, given the spectrum demand, the problem of interference between competing uses on various points along the spectrum is not going away. So I'd encourage the agencies and industry to find a way to safely coexist if possible. Believe that we can and must find a way for us to continue to encourage innovation in both the broadband and GPS industries. Finally, before I recognize Mr. Costello for his opening statement and other members, I'd ask unanimous consent that all members have 5 legislative days to revise and extend their remarks and include extraneous material for the record of this hearing. Without objection, so ordered, and now recognize Mr. Costello.
Mr. Chairman, thank you, and I want to thank you for calling the hearing today. I will submit my statement for the record. I welcome our witnesses and look forward to hearing their testimony. And with that, Mr. Chairman, I yield back.
Mr. Kovac, did you
have? Thank you, Mr. Chairman. I'd like to thank Chairman Petri and Ranking Member Costello for holding these important hearings on a critical importance of GPS in our nation's transportation infrastructure. I would like to welcome today's witnesses, and I look forward to hearing your testimony on the importance issue regarding the future of GPS. GPS is the cornerstone, as you well know, of aviation system that is in our country, and any threat to GPS needs to be handled with the utmost care and ensure that our skies are safe. One of my key concerns has been the Light Squared project and how it affects GPS devices. I'm very concerned that the reliability of GPS might be put at risk. I'll be interested to hear any opinions or any solutions to the situation because we need to solve all concerns before they become a problem and put lives at risk. I look forward to hearing from the witnesses their thoughts on the GPS and its role in our aviation system. Thank you again. I look forward to hearing from your testimony. And I yield back.
Thank you. Now we turn to our first panel, which consists of the Honorable John Porcari, Deputy Secretary of the United States Department of Transportation, Mr. Vincent Galati, who's the Deputy Director, Air Navigation Bureau, International Civil Aviation Organization, or ICAO, of the United Nations. Gentlemen, thank you very much for coming. Thank you for your prepared statements, and we'd invite you to summarize them, if possible, in about 5 minutes, and then we'll have some questions, I suspect. Thank you very much, and we'll begin with Mr. Porcari.
Thank you, Chairman Petri and Ranking Member Costello. Thanks to the members of the subcommittee. I appreciate the opportunity to appear before you today. The simple fact is the global positioning system applications are vital to transportation safety and efficiency. Tens of millions of drivers across America use GPS to navigate every day. In the Department of Transportation's Federal Aviation Administration, we estimate that by 2013, 60,000 aircraft will be equipped with GPS to navigate the skies over America. This is what we refer to collectively as NextGen. On the ground, positive train control, which is an improved safety application for rail transportation, relies on GPS as well. The intelligent transportation systems will depend on GPS as a key technology for vehicle collision warning and crash avoidance systems. What's more, GPS is essential for the operations of first responders, search and rescue, resource management, weather tracking and prediction, earthquake monitoring, and other critical national security functions. From there, the list goes on and on. Now, as you know, the LightSquared Corporation has proposed to create a wireless broadband network. In the Obama administration, we believe deeply in what LightSquared is attempting to do, which is to make the Internet more accessible to more people all across the country. This is an urgent national priority. But after comprehensive testing, we've concluded that their current plan to provide such services adversely affect GPS signals. And I'll be happy to delve into the details during our conversation, as I have in my written testimony. In short, both LightSquared's original and revised plans generate considerable harmful interference with GPS. Our researchers could find no obvious practical mitigations to solve the interference issues. I'd also point out that substantial federal resources, including over $2 million from the FAA, has been diverted from other programs in testing and analyzing LightSquared's proposals. Even if these interference issues were somehow resolved, LightSquared would still have to design fixes for known interference with high-precision GPS receivers that are vital for agriculture, science, and surveying. And LightSquared's operating plan still leaves open the possibility of broadcasting on both bands. Its FCC filings propose only a, quote, standstill on broadband use of the upper 10 megahertz band. Considering all these factors, the Executive Committee of the National Space-Based Position, Navigation, and Timing Group have now unanimously concluded that LightSquared's proposals are fundamentally incompatible with GPS use and that no additional testing or analysis is warranted at this time. Going forward, the XCOM agencies continue to strongly support President Obama's directive to make available a total of over 500 megahertz of spectrum over the next 10 years, suitable for broadband use. We recognize that we all have to do our part in spectrum use, making it as efficient as possible. We propose to work with the National Telecommunications and Information Administration in the Department of Commerce to draft new GPS spectrum interference standards. These standards, which would inform future potential commercial operators, would let them know in advance which uses in adjacent bands would or would not be compatible with GPS, and will ensure that this national policy protection for GPS evolves through clear communications with stakeholders, and that it's implemented without affecting existing and emerging uses of space-based position, navigation, and timing services that are vital to economic, public safety, scientific, and national security needs. In sum, our GPS system is one of the more vital, if less visible, parts of our national infrastructure. With that, I'll be happy to answer any questions. And again, thank you for permitting me to testify.
Thank you, Mr. Galati.
Thank you, and good morning, Mr. Chairman, Ranking Member, and Subcommittee members. It's an honor to be able to testify before this subcommittee, and I'd like to thank you for the opportunity. My testimony today will focus on the importance of what we call the global navigation satellite systems to international civil aviation. And there are a few other global systems. Russia has its Gnss, which has had some reliability and maintenance problems over the years, although that government is now committed to a next-generation system. There's the European Galileo, not yet operational, and of course China is in the process of launching its Compass system. Because of the reliability and continued upgrading of the GPS and the commitment of the United States government, GPS has evolved into the most fundamental and important piece of supporting infrastructure for the global aviation system. And just at the beginning, I'd like to mention that the United States is one of the primary contributors to ICAO in terms of technical expertise and knowledge and in support of consensus building and excellence in international standards and policy development, for which we are grateful. Most of the technical work that we do is accomplished by groups of experts nominated by the member states. The FAA has been the major contributor to ICAO in this respect, and I believe it has served U.S. interests extremely well. ICAO's close involvement with satellite navigation systems goes back to the work of the ICAO Committee on Future Air Navigation Systems, more commonly known as the FANS Committee. The U.S. was a major contributor and participant to that committee. In adopting the outcomes of the FANS Committee at the 10th Air Navigation Conference in 1991, a conclusion was reached that the exploitation of satellite technology appears to be the only viable solution to overcoming the shortcomings of the present system and also fulfill the global needs and requirements of the foreseeable future, and that satellite-based systems will be the key to worldwide improvements. In recognition of this turning point and acknowledgement by the world community of the importance of GNSS, which was highly dependent and is on the U.S. GPS, President Clinton formally offered the GPS Standard Positioning Service, SPS, to the global aviation community through ICAO to support international civil aviation. This commitment was reaffirmed in 2007 under President Bush as follows. The U.S. government maintains its commitment to provide GPS SPS signals on a continuous worldwide basis, free of direct user fees, enabling worldwide civil space-based navigation services, and to provide open, free access to information necessary to develop and build equipment to use these services. Even before the work of the FANS Committee and the offers of both Presidents Clinton and Bush, the availability of GPS to civil aviation first came about, as I'm sure you're aware, when President Reagan authorized its use for international civil aviation after the shoot-down of Korean 007. Following the initial U.S. offer, ICAO developed international standards to satellite navigation systems with the availability of the GPS system became globally recognized by the international civil aviation community as the central element of GNSS. ICAO and the entire international civil aviation community are now completely reliant on the long-standing U.S. government policy and its commitment as a key enabler to international aviation. And I just want to go over a few of the important ways that GPS supports international aviation. There are many areas in the world where the conventional terrestrial navigation and infrastructure is inadequate, and GNSS is often the only reliable source of navigation information. Before GNSS, navigation in high seas airspace was crude and inaccurate. Separation distance between aircraft used by air traffic control were as much as 100 miles laterally and 15 to 20 minutes in trail. The superior accuracy of GNSS, especially when integrated with sophisticated flight management systems, has enabled a number of substantial navigation improvements, which are the foundation of the concept of performance-based navigation, or PBN. In PBN airspace, separation between aircraft is significantly reduced, thereby increasing capacity while bringing safety, efficiency, and environmental benefits. The United States provides air traffic control services over vast expanses of high seas airspace. In the North Atlantic, there are over 2,000 crossings a day. The trans-Pacific passenger traffic is expected to grow by 4.2% between 2009 and 2030. Intra-Asia Pacific traffic during that period is expected to grow by 5.1%. And right now, there are approximately 8,000 flights per year that operate on cross-polar routes, and they are totally reliant on GPS. Until very recently, all final approaches to land at major airports were accomplished by means of instrument landing systems. This is okay in states that are able to maintain these and that have the infrastructure to support that. In many parts of the world, maintaining such systems is prohibitive because of the cost and expertise. Using PBN approach procedures based on GPS, more and more approaches to land are accomplished by means of the equipment in the aircraft only, with little or no reliance on ground equipment, bringing enormous safety benefits. And airports that previously had no instrument approaches now have PBN. Today, when U.S. airlines fly into Lagos, Nigeria, Almaty, Kazakhstan, Ulaanbaatar, Mongolia, Dakar, Senegal, Quito, Ecuador, and Georgetown, Guyana, to name but a few out of hundreds, they are more assured of safe operations because of GPS. GNSS is important for next-generation aircraft surveillance, and I'm sure you're all aware of automatic dependent surveillance broadcast. But over oceanic airspace, automatic dependent surveillance contracts allows air traffic control to have surveillance where this was impossible. And finally, two of the most significant near-term air traffic management improvements that have recently become available are continuous descent operations and continuous climb operations. This is a major initiative at ICAO, and GPS allows this extremely efficient flight routing to be enabled. And now just a few words about the spectrum. Major issue that has as much to do with the importance of GPS as anything else. I'm referring to the problem of frequency spectrum. Available radio frequency spectrum is the lifeblood of aviation, and the protection of spectrum used by aviation radio systems is absolutely essential for safety. ICAO has been vehemently supporting the protection of GNSS spectrum for decades in all international fora, especially the World Radio Conferences, and there's one going on in Geneva right now. Against that background, I would urge you to consider that any decision by the United States that affects frequency spectrum, which impacts on GNSS, will have a critical impact on the safety record, the investments made in GNSS, the international standards, and the recertification of equipment. In summary, Mr. Chairman, I would like to appeal to you and the committee that ICAO and international civil aviation continue to benefit from U.S. leadership and cooperation in many ways, including invaluable support through the sharing of technical information and expertise, support of consensus building and excellence in international standard and policy development, and concrete projects to assist countries in need of strengthening their aviation programs. GPS is among the most important ways that the U.S. provides technological, humanitarian, and political leadership. ICAO looks further to deepening this relationship and working together. Thank you for this opportunity to share ICAO's views with this important subcommittee.
Thank you both. At previous hearings, this subcommittee has been informed that as we gain momentum in deploying the next-gen technology, it will have an enormous return on the American government's investment in it, reduce fuel use for the industry by some 20 or 30%, expand the capacity of the system without having to build additional runways and so on, improve the safety of the system, shorten the time of flights, and it goes on and on and on. So reduce the sound footprint as planes are able to glide down more for many of the airports where that's been a problem. A lot of benefits from this new tech, for using this technology in the aviation industry, as other industries have found. I do have a couple of questions. First, Mr. Portkari, you mentioned that you proposed the Department of Transportation work with the National Telecommunications and Information Administration to draft new GPS spectrum interference standards to strengthen existing national policy protection of adjacent band spectrum. Could you elaborate on what that all means?
I'd be happy to, Mr. Chairman. And one thing that I think recent events has showed us is that GPS is not only a national asset, infrastructure asset, but that protecting that asset, we're going to have to be much more sophisticated in the future in how we do that. In layman's terms, on both sides of the existing GPS frequency, there were mobile satellite type applications that were also quiet, as it were, that did not interfere with GPS's ability to hear what is a very weak signal from space, basically 50 watts, 22,000 miles up. the spectrum interference standards, and we would take a whole of government approach to this, working through our Position, Navigation, and Timing Executive Committee. The idea would be to identify before anyone puts capital at risk or major project at risk, what are compatible uses to GPS. In general terms, the more precise the GPS receiver, for example, the avionics in an aircraft, the more precise they are, the more that they are likely to have a wideband receiver that in fact needs to be able to listen beyond the GPS frequency. Acknowledging that and building a policy around that would be, we think, a very good use of staff time, and from a policy perspective, critical to protecting GPS as an asset.
We're proposing to set interference standards. How is the proposal to set interference standards different from setting receiver standards?
There are currently no receiver standards, and the idea of spectrum interference standards would be to give everyone involved, the industry and others, confidence in the long term that as they build more and more precise GPS devices, and I know our focus is on aviation, where GPS is absolutely critical to operations today, but will be even more so in the future. But other applications, precision farming, construction, and others, spectrum interference standards would be clear guidelines for all users, both within the GPS spectrum and adjacent spectrums. We think if we can build the kind of consistency and predictability for both the GPS users and adjacent spectrum users, that will serve everyone's interest well.
I understand there is some sort of a kerfunkle about the adjacent, who's interfering on whose turf in this particular area, and that in fact it was allowed for a little broader use of spectrum because it didn't interfere with adjacent use, and then when the type of use was changed somewhat at the staff level, that has created a problem. Is that what you're trying to avoid?
Yes, Mr. Chairman, that's exactly it. GPS by its very nature is a very weak space-based signal that's very faint when it's received by GPS receivers in the atmosphere or in terrestrial applications. I think of it in zoning terms because that's probably the way to think about compatibility of uses. GPS the spectrum was originally put in a quiet neighborhood because it needed a quiet neighborhood with quiet neighbors to be able to have accuracy in receivers. The adjacent pieces of spectrum were for mobile satellite service, which was another quiet use. What has happened with this specific proposal is essentially you went from a mobile satellite service proposal with limited ground augmentation to a ground-based service with limited satellite augmentation. And that really changed the fundamental nature of signals and how they would be received. But it's, I think, really important to point out that GPS was put in a quiet piece of the spectrum on purpose because fundamentally it has to have quiet neighbors.
So this was well known at the technical level at the time this strategy was put in place?
Yes, I believe it. The physics and the technical parts of it have been well known all along. And I'd also point out that as Mr. Galati had, from an international perspective, harmonizing that use of the frequency internationally was important as well, so that the same kind of safety of flight avionics that we're using today, and as we build a larger next-gen system of systems, can be used around the world.
Mr. Galati, in your testimony, you referred to the GPS spectrum use being under some threat and it being discussed at past World Radio conferences and I think some current or upcoming conferences as well. Could you elaborate on that and what role you as representing the global aviation industry play in those conferences, and how you've been able to work out resolutions in the past?
The International Telecommunication holds a World Radio Conference every 3 years, and it's a huge event. It lasts for 4 weeks. The states go with very powerful representation, and also industry goes with incredible force. Telecommunication providers are, as you can imagine, have the most to gain, and they put a lot of pressure. They work around the clock virtually. I'm getting emails from my people at 2 and 3 in the morning. ICAO is an observer, but during the 3 years in between, we meet with all of our member states, and we prepare an ICAO position that at least the member states agree to. So we get just about unanimous decision on the ICAO position for radio frequency spectrum. It doesn't always pan out that way at the event itself, because again, there's a lot of lobbying, there's a lot of pressure, a lot of jobs at stake. But as observers there, we do have a lot of close contacts with the states and with friends in the aviation industry, and we have been very successful in working with the member states, and the United States has been a strong supporter of protecting the GBS spectrum from other uses. Thank you.
Thank you. Mr. Costello.
Mr. Chairman, thank you to Deputy Secretary Picari. To follow up on the Chairman's question, he asked the same question that actually I was going to ask, but I'd like to have you clarify a point. My understanding is that you are proposing that DOT work with other agencies to develop a policy. Does that mean for radio transmission standards in the spectrum? Is the interference now between the agencies, are we talking about transmission standards, or what are we talking about?
What we're really talking about is more generically and more broadly spectrum interference standards, where we could establish by consensus and with input from everyone who has an equity in this, industry, interested observers and others, the kind of standards that would protect the GPS spectrum both today and in the future. And if you look at the evolution of GPS, just in the last 10 or 15 years, for example, the GPS uses, especially in aviation, have gotten more and more precise, and they are now safety of flight issues, which requires spectrum interference protection.
We're talking primarily about transmission standards.
We're talking about primarily the requirement for precise navigation devices that use GPS to be able to utilize as broad a band as possible, which they have been to date, and which was acknowledged in the original approval of mobile satellite services on either end of that spectrum. So I say this because, in fairness to all the potential users outside of the GPS band, establishing those standards would give them a good sense of what kind of uses would be compatible and which would not.
You also mentioned in your testimony that the Obama administration, that their goal is to free up federally owned spectrum and make it available for mobile broadband, especially providing access to underserved rural communities. I certainly support that goal, and I think many members of the committee would as well, especially for underserved communities for wireless service, then where consumers would benefit from competition between service providers. Let me ask, if the mobile satellite service band is not compatible with the high-speed wireless transmissions, then what can the administration do to provide greater access to high-speed service?
Well, the administration, the Department of Transportation and every part of the administration is again committed to identifying those 500 megahertz of additional spectrum over the next 10 years. We strongly support what you've underlined, which is the need for rural broadband and broadband competition. There are some features of the recent proposal that are very valuable from that perspective. But we think that working across the government with our Position, Navigation, and Timing Executive Committee, with NTIA, will ultimately be helpful. Obviously, we would not presume to in what actions the Federal Communications Commission, an independent agency, would take.
Thank you, Mr. Chairman.
Mr. Coble.
Thank you, Mr. Chairman. Gentlemen, thank you for your testimony. Mr. Petri, are there immunity standards for military GPS receivers that protect them from transmissions from outside the GPS band?
Congressman, my understanding, and I believe General Shelton testified before this at the House Armed Services Committee, is that there are not. And I do know that in at least some cases, the Department of Defense aircraft are using commercial off-the-shelf avionics that are FAA certified for commercial use as opposed to military.
Thank you, sir. Well, let me ask you another question, Mr. Petri. What standards are currently in place to make sure that the receivers and equipment purchased pick up only signals using the GPS frequency band?
There are no current standards in place, and that is part of the reason for the discussion. And again, we think going forward, having the consistency and predictability of spectrum interference standards will help all parties involved.
Thank you, sir. Mr. Galati, I'll put this question to each of you. What impact might protections for GPS have on the marketplace for radio spectrum, A? And B, how does this bear on the question as to whether or not GPS warrants protections? Either of you is fine. Mr. Galati, we'll start with you.
Thank you, Congressman. I guess there are various figures that exist as to the number of jobs and the value of spectrum. And as I've said earlier, there's tremendous pressure from the telecommunication providers who have significant figures on jobs. But on the other hand, aviation globally, I believe a number that's out there is worth about $3 trillion to the global economy a year when you consider the economics, the tourism, the aviation industry itself, the business carriage of goods and other things. So probably a good case could be made that economically aviation is critical, but there will be more and more pressure from particularly the telecommunication providers. Thank you.
Particularly from whom?
The telecommunication providers.
Right.
Sorry,
I didn't hear you.
Thank you, sir.
Carl, you want to weigh in?
Yes, Congressman. I don't know the values of the spectrum in itself. I would point out that the national investment we've made in GPS, first from a military-only perspective and now from a combined military-civil perspective, has been enormous. It's one of the more precious and important pieces of national infrastructure we have, even if you can't see it and feel it. It's also a U.S. national leadership issue. I would point out in the aviation context, I'd argue that one of the single best safety advances we've made in the last 20 years, which is the terrain avoidance warning system. 20 years ago, controlled flight into terrain for both commercial and recreational aircraft was a leading cause of accident. The terrain avoidance warning systems that are GPS enabled have taken controlled flight into terrain from a leading cause of accidents into something that's way down on the list. Another example is as of today, part of our next-gen system, ADS-B, is operational in the Gulf of Mexico, where we have had no radar coverage. And we have thousands of flight operations a day, for example, serving offshore petroleum rigs via helicopter that had no radar coverage before that are now served by ADS-B. So it's important to make sure that we understand the value on both sides of the equation, including the enormous national investment that has been made in GPS, which has gone far beyond military uses, has gone far beyond aviation uses, and for precision farming, construction, safety of our train systems, those are not possible today without GPS.
Thanks, Mr. Chairman. My red light is about to illuminate, so I'll yield back.
Thank you, Mr. Duncan.
Well, thank you, Mr. Chairman. And this is my first real involvement with this, so there's much of it that I don't really understand. But, Mr. Secretary, I have read this statement from this assessment. It says by the Deputy Secretaries of the Department of Transportation and the Department of Defense, and I assume that's from you?
Yes.
And it's a very strong statement that you put out about 3.5 weeks ago. And you say there that you mentioned that Light Squared had an original proposal and then they modified it. Can you explain to me in layman's terms how much of a change they made in their original plan? It also tells us in our briefing papers that they're disputing your findings or your assessment.
I'll be happy to, Congressman. Okay. And layman's terms is all I'm capable of here, so okay. I'll try to do it in that sense. The original Light Squared proposal of roughly a year ago, January of 2011, proposed up to 40,000 ground-based transmitters that would effectively blank out the GPS signal in large stretches of the U.S. and in some very critical areas. There was some early testing done, both by the Department of Defense and the FAA. It was clear from that testing that there was an interference issue. The forum for this is a relatively obscure group, the Position, Navigation, and Timing Executive Committee, which the Deputy Secretary of Defense and I co-chair. Deputy Secretary Carter representing the military users and myself representing all the civil users. Through that committee, which includes all the executive branch agencies, which includes others, including the Federal Communications Commission as an observer, it was clear that additional testing of a different proposal was in order. We worked with Light Squared. They were part of developing the testing protocols. They were part of the testing itself. And the results, I think, are very clear-cut. I would point out that those are the testing results from both the NPEF work and separate Federal Aviation Administration work are currently with NTIA and will be transmitted to FCC shortly. But those results were independently verified by both the Idaho National Engineering Laboratories and then the Lincoln Laboratories at MIT. From my layman's perspective, the result, especially with the precision safety of flight avionics that we use in aircraft, the results were unacceptable.
Well, let me ask you this. I said it was a very strong assessment, and what I'm talking about, it says, based upon this testing and analysis, there appears to be no practical solutions or mitigations that will permit the Light Squared broadband service as proposed to operate in the next few months or years without significantly interfering with GPS. I understand that the dangers or the concerns or the problems, but it is a fascinating thing to me that you could say that there's nothing that they could even do within the next few years. It does tell us, and I have no connection whatsoever with Light Squared. I've never even talked to these people, but it says they dispute these findings. How do they dispute them? Do you know? Or could you tell me something?
First, I believe the Light Squared representatives can and should better explain how they dispute the findings. I would point out that the statement, Congressman, is strong. I believe it's warranted given the circumstances. When we talk about in the next few months or years, remember there's a very large installed base of GPS receivers. Just focusing on aviation for a moment, there's about 60,000 GPS receivers out there that are used for safety of flight things like terrain avoidance warning systems. Each of those is about $40,000. If you look at on average, if you look at the life cycle of aircraft and avionics, they serve for decades. And the reason for that part of the statement is to point out that there's no easy retrofit or filter or any other kind of retrofit that would, from a safety of flight perspective, make the proposal as currently proposed by Light Squared compatible with aviation.
Well, I'm not saying it wasn't warranted. I just said just was saying it's a fascinating thing that there would be a statement that nothing could be done even in the next few years when technology advances as fast as it does. So it's kind of an interesting thing. Thank you very much.
Thank you, Mr. Lobianto. Mr. Cravath.
Thank you, Mr. Chairman, and thank you for your testimony today. I can truly tell you as a pilot, there was a palpable difference in the cockpit when you have terrain-avoided systems using GPS. When you're flying that approach coming in from the east, going into Salt Lake City, and you know you're skirting the top of those mountains, it was really a comforting feeling to have that GPS in the cockpit. But Light Squared has agreed to a standstill, as I understand it, on the use of the upper portion of the spectrum, and it's the portion that's actually closest to the GPS signal. And Light Squared has stated that it would like to work on the GPS community to develop mitigating strategies, as they put it, in order to initiate commercial operations of the upper spectrum within 2 and 3 years. Is, in your opinion, I understand when your testimony you said there is no mitigating conclusion here, in that do you really think 2 or 3 years to be able to find some type of strategy is in that window? And two, from what we know, even though we really can identify a mitigating strategy, the cost to general aviation to implement that strategy as well. So.
Thank you, Congressman. First, I'd point out I'm not sure what a standstill means on the upper 10 megahertz. It's not. There are no time limits to that, and no technical triggers that I'm aware of on that. There is a fundamental incompatibility between the Light Squared proposal as proposed and the continued use of GPS as a precision air navigation use. And again, I would point out that this has been built over decades now, where more and more we are dependent on GPS for a much higher standard of safety than we were able to achieve with the old instrument landing systems, without the terrain avoidance warning systems, without wide area augmentation systems. All of those are very significant safety advances. I can't speculate on the cost because I'm not sure anyone can quantify the cost, even if it could be done, of retrofits, if they were technically viable, to existing avionics uses.
So just to be clear then, there is no plans at this time to retrofit or reconfigure any systems to work Light Squared into this bracket. Is that correct?
That is correct, Congressman. I would say, in contrast, mobile satellite service uses on the adjacent frequencies, which is what they were originally zoned for, if you will, have been and will be compatible.
Super. Thank you very much, and I'll yield back.
Thank you, Mr. Fleischman. Mr. Ribble. Mr. Farenthold.
Thank you very much. And I'm troubled that a terrestrial-based system like Light Square has the potential for interfering with GPS. I'm afraid it points out the actual delicate nature of the GPS system and its potential vulnerability to be, for nothing else, an attack. You hear reports of a truck driver with a jamming device degrading the system near Newark Airport. Suppose someone not friendly to this country were to intentionally put up some high-powered jamming stuff. We would be in trouble. Historically, LORAN has been considered a backup to GPS, but that's currently being dismantled. I'm concerned that we have all of this reliance on GPS, from everything from my car to my cell phone to landing a 777 aircraft in the future. it seems to me that we're creating a vulnerable system with no backups. Can y'all comment on that?
Yes, Congressman. First, you've brought up a very important point. There are, by its very nature, there are vulnerabilities for the GPS. You pointed out one specific incident where a commercially bought over the Internet $99 jammer caused real issues at one of our major airports in the country. One of the things that we've done is a national position, navigation, and timing architecture study of the overall system architecture. And following on that, the Federal Aviation Administration is committed to an alternate PNT research program where just as today with our terrestrial radar-based air navigation system, we have vulnerabilities and you basically build defense in depth with backup systems. We know as we move with the implementation of NextGen, as we move forward with that, that it will be more and more important to have backups to the GPS-based system. They will only be short-term backup systems, and it's important to point out that we're moving aggressively.
Could you define short-term backup? I don't.
Well, I mean for short duration. In other words, if we were denied the use of GPS systems for air navigation today for an extended period of time, it would have severe impacts on the national airspace system. If it were for 10 minutes, it would be a little bit different.
Okay.
So
minutes as opposed to days.
Minutes as opposed to days. But again, you've put your finger on a vulnerability in the system that
it seems vulnerability easy to exploit.
Well, it can be, and part of this is the architecture and design going forward of how we design the system of systems that is NextGen. We're very focused on this. Also, I would point out there's an important enforcement side. There is no legitimate commercial use for a GPS jammer.
All right. And just for my information, I know that I've seen press reports about other countries developing their own GPS satellite arrays. Do we know where that's going?
Thank you, Congressman. The Russian Federation had established their system in the 90s, and when the Soviet Union disintegrated, it was not maintained. But I understand as of December of 2011, now they have a full constellation, and they've committed to GLONASS-K, which is similar to GPS-3, and they hope to have that in place by 2014. The Europeans have Galileo, which 2 satellites are up. I think the total constellation is, I believe, 18, and China is putting in place what they call Compass or Beidou. They have 2 satellites in place, and they plan to launch 6 in 2012 and the full complement by 2020. And that'll initially be for East Asia and China, parts of the
And if you'll allow me just to geek out for a second, we've got a massive array of radio transmitters in the form of our cell tower network that can contain longitude and latitude information of the cell towers. Is any research going into tapping into those to create some sort of system as a fallback to GPS?
I don't know. What I'd be happy to do is actually research that and get back to the committee.
Just curious. It seems like there's an infrastructure in place. You might be able to develop a fallback system.
I appreciate the question, and I'll find out.
Okay. And my time has expired. Thank you.
Well, I'm sure we all have a lot of other questions, but I will leave it there for the purpose of this hearing at this point. Thank you very much. It's been very, very informative.
Thank you, Mr. Chairman. Thank you, member.
The second panel consists of Mr. Thomas L. Hendricks, who is Senior Vice President of Safety, Security, and Operations, Airlines for America, Captain Sean Cassidy, First Vice President, Airline Pilots Association, Craig Fuller, President and CEO of the Aircraft Owners and Pilots Association, John M. Foley, Director, Aviation GNSS Technology of Garmin AT Inc., and Dr. Scott Pace, who's the Director of Space Policy, the Space Policy Institute, Elliott School of International Affairs, the George Washington University. I thank you for all of you for making the time to be with us today on this very somewhat technical to a layman, but very important subject for sectors of our economy and our safety and competitiveness as a country. And we'll begin with Captain Cassidy, waiting for Mr. Hendricks.
Well, it's still morning. Good morning, Mr. Chairman and the members of the subcommittee. I am Captain Sean Cassidy, First Vice President of the Airline Pilots Association International, and I represent more than 53,000 professional pilots based in the United States and Canada. It is an honor to appear before the subcommittee to underscore the tremendous contribution that the satellite-based navigation system makes to ensuring efficient and safe operations in the United States and around the globe. Given the vital importance of the global positioning system as a key component of this country's transportation infrastructure, it is appropriate and indeed essential for the House Transportation and Infrastructure Committee and this Aviation Subcommittee to be fully engaged in protecting this system. As the members of the subcommittee know, over more than 2 decades, the invaluable navigation information available through GPS has enabled air transportation to make tremendous gains in safety and efficiency. Since 1983, when GPS became available to the public at no cost, the system has evolved to become a vital tool for aircraft navigation, all-weather approaches and landings, surveillance, maintaining required separation between aircraft, and pilot situational awareness. GPS allows pilots to fly aircraft using the safest and most efficient routes, which benefits every flight operation, but particularly those over the Atlantic and Pacific, or on transport long-range routes where diversion options are very limited. The enhanced accuracy of GPS also allows aircraft on parallel runways to operate independently, safely increasing arrival rates. In major metropolitan areas that are served by several airports, GPS allows us to analyze the entire airspace and operate flights based on a regional strategy rather than airport by airport. These opportunities to improve flight operations, possible only through GPS, reduce fuel burn, decrease noise, and cut CO2 and other greenhouse gas emissions while making our industry safer, more efficient, and better positioned to meet future demand. Let me give you one example from my own flying experience. The airport at Juneau, Alaska, the state capital, is situated on a base surrounded by high terrain. Before GPS, we pilots only had 2 choices for approach and landing at Juneau, and they're both very challenging. The approach from the east and the one from the west both required fairly high cloud ceilings and a tight turn at low altitude to line up for landing. Without GPS, the terrain and weather conditions forced many flight cancellations. In 1996, Alaska Airlines pioneered a GPS-based instrument approach to Juneau, Alaska. The pinpoint accuracy of the GPS approach allows me to fly directly over the center of the Gastineau Channel, as depicted in the photo up on the screen, and stay clear of the high terrain surrounding the channel and the airport. The result enhances safety and reduces delays and cancellations. Since then, the Alaska Airlines has expanded the GPS-based approach to other airports in the country. In 2011, the airport completed more than 1,500 flights that would likely have been canceled or diverted, and the net result was $19 million worth of saved revenue and over 210,000 gallons worth of fuel that was not burned. Across the United States, the FAA has published more than 11,000 GPS approaches to thousands of airports, including our own backyard here at Reagan National, where highly accurate GPS-based approaches reduce flight delays, diversions, and cancellations. GPS signals are low-powered by design to allow them to be based on satellites. However, this low-energy environment also makes them susceptible to interference from other radio transmissions. For this reason, only low-powered satellite-based signals have historically been permitted in the radio frequencies that are closest to the GPS bandwidth. One recent proposal to deploy 40,000 high-powered ground-based transmitters in the radio frequency spectrum that is directly adjacent to GPS bandwidth raised alarm as a result of the risk it posed to the safety of air transportation, as well as to emergency services such as first responders. Rigorous industry and government testing demonstrated that if LightSquare proposal had been allowed to go forward, GPS would be inaccessible over large regions of the U.S. at normal operational altitudes for airliners. Were this proposal or anything like it to be allowed to proceed, pilots will lose a tremendous navigational tool that is especially important in mountainous terrain, remote areas, and bad weather, and that supports a safe and efficient air transportation system that helps drive the U.S. economy and secure tens of thousands of jobs. Looking to the future, GPS is critical to our efforts to modernize the U.S. air traffic control system through NextGen. ALPA is a staunch advocate for NextGen because of its enormous potential to enhance safety, increase capacity and efficiency, and protect the environment. As part of the NextGen initiative, the FAA has already invested more than $1 billion in GPS-based technology that is designed to replace radar-based surveillance of aircraft. As NextGen continues to mature, GPS will become more important. The pilots of ALPA commend the U.S. Aviation Subcommittee for holding this hearing and allow us to underscore the unmatched benefit that GPS provides to air transportation both now and in the future. Thank you very much.
Thank you. Mr. Hendricks.
Chairman Petri, Ranking Member Costello, and members of the subcommittee, thank you for inviting us to appear at this timely and important hearing, and I do apologize for my slight delay in my pushback for my testimony this morning. It's good to speak with you again. The continued integrity of the global positioning system is critically important to the millions of customers who we fly every day, as well as to the tens of millions of other people in our country who rely on it. GPS will be the backbone of air navigation both domestically and internationally in the coming years. Interference with its accessibility and reliability would be catastrophic for civil aviation and the communities that depend on air transportation. We deeply appreciate the subcommittee's recognition in the FAA reauthorization bill of the importance of this technology and particularly your support for the continued advancement of NextGen. With respect to the light squared proposal, the incontestable fact is that it will create widespread GPS interference, which will have ruinous effects on aviation. Experts have repeatedly reached that conclusion. Light squared's proposal, therefore, should be withdrawn. This matter needs to be put to rest once and for all. To be clear, we do not oppose the expansion of wireless broadband services, but any expansion cannot be permitted to interfere with existing or anticipated aviation GPS use, many of which will significantly enhance safety. We are dependent on that technology. There is no substitute for it. One obvious lesson of the convoluted experience with the light squared application is the need for a government-wide policy that protects the aviation GPS spectrum. Without such an authoritative policy, spectrum encroachment will remain a threat. As the subcommittee knows all too well, we have historically relied on a ground-based air navigation system. It is a system that has become increasingly defined by its limitations. Users of the system have, for the most part, had to fly from one ground navigation aid to the next, often resulting in circuitous routings. This inefficiency wastes time and fuel. It also restricts the number of routings that aircraft can use, which in turn constricts capacity growth. GPS is at the heart of the ongoing multi-billion-dollar NextGen program that will shift air navigation from that outmoded terrestrial system to a modern satellite-based system. This is a transformational change. All who are involved in it, Congress, the Federal Aviation Administration, airlines, general aviation, and the Department of Defense, recognize the need for that transformation. This massive effort will result in more precise navigation, safer operations, far more direct aircraft routings, better airspace utilization, and airspace capacity growth. Because of these operational improvements, there will be substantial reductions in greenhouse gas emissions. One existing application of GPS has produced a breakthrough in the safety of airline operations. It's been referred to earlier here. The elimination of controlled flight into terrain accidents for large jet aircraft in the United States. Enhanced ground proximity warning systems aboard aircraft combine GPS information with onboard terrain databases to provide flight deck crews with look-ahead warnings of dangerous terrain. This has made air travel far safer than it was only recently and illustrates the remarkable benefits that leveraging GPS with other technologies can achieve. The introduction in the coming decades of next-gen capabilities will be the real game changer. Its integration of GPS with other technological innovations will create the satellite-based system of air traffic management that we all realize is necessary. GPS is the indispensable element of this long-needed overhaul. Given the essential role of GPS, the federal government must develop comprehensive safeguards for aviation's use of it. The stakes are too high for the passengers and shippers that rely on air transportation, the communities and businesses that depend on air service, and airlines and their employees to leave to chance our continued ability to utilize GPS to the greatest advantage. Consequently, we need a government-wide policy that guides federal agencies' responses when potential interference issues emerge. That policy must make clear that interference in the aviation spectrum is prohibited and that other users cannot be permitted to encroach into the aviation spectrum. Domestically, the most obvious place to begin to strengthen governmental policy against GPS interference is the National Executive Committee for Space-Based Positioning, Navigation, and Timing, the PNT. The PNT is a government organization established by presidential directive to advise and coordinate federal departments and agencies on matters concerning GPS. The PNT is chaired jointly by the Secretaries of Defense and Transportation and includes equivalent level officials from the Departments of Homeland Security, State, Interior, Agriculture, and Commerce. The Federal Communications Commission chairman participates in the PNT as a liaison. At the very least, the FCC should be required to consult with the PNT before taking action on any application to operate a terrestrial-based communications network that may affect the L-band spectrum, which is the band that GPS uses. On the international front, U.S. government positions expressed at international conferences at which spectrum issues are considered, such as the World Radio Communications Conference that is currently being held in Geneva, must reflect the importance of protecting the GPS spectrum throughout the world. We appreciate the subcommittee's interest in this vital issue. We're prepared to assist you in any way we can, and I'd be happy to take any questions you might have.
Thank you. Mr. Fuller.
Good morning, Mr. Chairman, Ranking Member Costello, Craig Fuller, President and CEO of the Aircraft Owners and Pilots Association. It's always a pleasure to be before the committee. I'm going to start with a statement I don't always get to make, and that is that we are in absolute full agreement with the Obama administration on the question before you today. I thought the statements by the Deputy Secretary of Transportation were right to the point. We agree with every point that was made there. Indeed, the other members of the administration, other departments and agencies that have looked at this are of the same view. There's only one somewhat reluctant regulator out there that seems not to have gotten this message, but perhaps today's hearing will help, although I know that's a topic maybe for another day. I have a statement I filed for the record. It makes many of the points that have been made. I thought I'd give just a couple of comments from a little different perspective. You know, we all say GPS is extremely important. We certainly believe that. But in a way, GPS is pretty simple. I took off yesterday from Frederick, Maryland in an aircraft, and as soon as it was airborne, in fact, even before it was airborne, a small box in the plane received multiple signals from GPS transmitters in space. All that box did initially was identify those signals and determine precisely where it was. That's GPS. The genius of GPS is what it enables. The fact that GPS has been around for a long time as a technology that can determine precisely where something is in space doesn't mean that this is somehow old and not exciting, because the excitement in GPS is what it enables. The fact that that box, as I traveled, kept determining exactly where that airplane was in space. You now have 2 points. The box calculated my airspeed. The box calculated my heading. The box calculated that there's towers on hills near Frederick, Maryland, that I was within 500 feet of. If I had an emergency of some kind, the box would tell me exactly where the nearest airport was, what the route was to it, how long it would take me to get there, simply because it could receive this very small signal from space, from the GPS transmitter. And I guess I would submit that while some may say, well, it's time to look to new technology for greater benefits, we've just begun to tap this genius of GPS and what it can enable. And as you've heard today, it is absolutely at the center of next-gen technology. We have 5,200 public-use airports in this country. We couldn't possibly afford to put instrument landing systems in all those airports with equipment on the ground. And yet every one of those airports can have a precision approach to every runway on the field using GPS capabilities. That's what it enables. It enables emergency helicopters to go precisely to the scene of a crime, to a mountain climber that needs to be rescued, and know exactly what the closest landing site is for the helicopter. All these things are enabled by this GPS signal. So I guess from where we sit, my 400,000 members who are flying general aviation airplanes see this as absolutely essential. By the way, you've heard from two very respected members of the industry who fly large airplanes. The airplane I was in was a two-seater Aviat Husky, and it has this same GPS capability that airliners have. You know, I think when we talked about this issue before, I said there's nothing wrong with a government agency looking forward and seeing an opportunity and letting it be explored. And indeed, the Food and Drug Administration does that all the time with miracle cures and medicines, but sometimes they don't work. And I think what the agencies of the federal government have said is we embrace the concept that was being considered, but the approach simply doesn't work. And it puts at risk all that GPS enables, which is not only what we've experienced for the last 20 years we've been using it, but the promise that it holds for the future. So we very much appreciate the committee's interest in this. We certainly embrace, as I said, the statements made by the administration. We strongly urge that the Federal Communications Commission rescind waivers that keep this cloud over us on this important topic until further research can be done. Thank you, Mr. Chairman.
Thank you. Mr. Foley.
I'm grateful for the opportunity to participate in this important hearing. I'm John Foley, Director of Aviation GNSS Technology at Garmin. The 9,200 people at Garmin are devoted to designing and building GPS devices for millions of users worldwide, improving their lives and safety. The GPS industry in this country alone accounts for over 130,000 direct jobs. What was once a government-only technology is now fully woven into the fabric of our infrastructure. That did not happen overnight. It has taken 2 decades of hard work to mature it from a fledgling technology into a reliable force for safety and efficiency. Yet, unbelievably, what we have built together is now threatened. Today, virtually all types of aircraft utilize GPS for navigation and approaches. Loss of even a fraction of GPS reliability would pose significant danger to aviation safety. 4 areas are particularly worrisome. Loss of GPS while on approach would unsafely increase pilot workload during a critical phase of flight. Loss of GPS would deny coverage at hundreds of airports and heliports lacking ground-based navigation aids. Without GPS, the Terrain Awareness and Warning System, or TAWS, would not work. Loss of GPS means a loss of situational awareness for cockpit displays of traffic and weather information, including on the ground to prevent runway incursions. Last but not least, reliable GPS is essential for the FAA's proposed next-gen system. We can sum up the last year in 4 words: grant first, test later. Grant first, test later seems to stand the process of public decision-making on its head. This approach placed a severe burden on everyone's time, attention, and resources, a burden that should have been placed on those seeking something from the FCC. Everyone concerned about GPS reliability had to devote 6 months last spring and millions of dollars to testing the effects of constantly changing proposals. The test revealed extensive interference. Anyone aware of the tremendous difference in signal strength between GPS and a high-powered terrestrial network could have predicted this result. Yet, despite all this, another round of extensive government testing occurred last fall. The PNT XCOM again concluded in a recent letter to the NTIA that various plans for a high-powered terrestrial broadband network would cause harmful interference to many GPS receivers. The letter noted that the FAA's separate analysis similarly concluded that such proposals are not compatible with several GPS-dependent aircraft safety systems and that no practical solutions exist to prevent significant interference to GPS. The XCOM stated that no further testing was necessary. Garmin has found many developments over the last year to be troubling. Why did the FCC make a far-reaching decision without conducting its own tests or spending time to evaluate Garmin's first test results? Should an applicant have the burden of demonstrating market readiness? Why were objections from the Departments of Transportation and Defense ignored? We hope you are asking these same questions too. Well, where do we go now? We believe that the PNT has the right structure, the right stakeholders, including a liaison role for the FCC, and on paper should be effective. However, future coordination must be improved. The FCC should obtain PNT XCOM sign-off when proposals before it potentially interfere with GPS reliability, the level of reliability that our customers have come to expect. Going forward, if the PNT believes that the creation of a post of something akin to a national chief GPS officer would help ensure that coordination, we could support that. We think such an officer should alternately come from the Departments of Defense and Transportation. In their recent letter to NTIA, the XCOM said that they proposed to draft new GPS spectrum interference standards. In response, we simply note that in the last year, parts of our government seemed unaware that, at least for certified aviation GPS devices, the FAA and Department of Defense standards already address interference. Any analysis in the future should recognize and build upon that work. In short, Garmin and other manufacturers have had their businesses greatly disrupted by the failure of government to effectively coordinate. It has cost us millions of dollars and thousands of person-hours that could have been better spent improving GPS products. If anything, for businesses, consumers, and the nation, this year has in essence been a trial run. We've learned a lot, but the threat is still there, and we need your continued vigilance to help. Thank you, and I look forward to answering your questions.
Thank you, Dr. Pace.
Thank you, Mr. Chairman. And thank you to this committee for an opportunity to discuss this topic. As you've heard, GPS is a global utility that's critically important to all modes of our nation's transportation infrastructure. What I'd like to do is provide maybe a little historical or policy perspective, because some of these issues of threats to GPS are actually not new. There have been and continue to be many policy and legal risks for GPS, from funding constraints, the transition to modernized signals, international trade barriers, and domestic regulations. The most serious threats, however, are not to be GPS itself, but to the spectrum environment upon which it depends, if you will, the foundation upon which all these applications reside. Every type of threat, from band sharing, segmentation, out-of-band emissions, noise floor increases, reallocation of adjacent bands, have been attempted over the past 15 years. To date, all such threats have been removed or mitigated through government industry cooperation and through bipartisan support from multiple Congresses and administrations who sought to protect the spectrum in which GPS operates. 4 presidents, 2 Republican, 2 Democratic, have issued policy statements regarding GPS. These statements have recognized the dual-use nature of GPS as more than a military system, crucial to a broad range of U.S. interests. Similarly, Congress has passed numerous bills related to the protection of GPS, and federal statutes can be found under both Title 10, Armed Services, and Title 51, National and Commercial Space Programs. Regulatory processes for rulemaking are well defined in the Administrative Procedures Act. I would say that the United States has sufficient law and policy on the books to protect GPS. What has been missing at times has been a willingness to enforce those laws and procedures and follow the basics of good government. Given the high stakes involved in preventing risk to GPS, it's tempting to look for a special policy fence that would automatically prevent problems from arising. Given the FCC is an independent regulatory commission, however, that does not report to the President, any special policy fence for GPS will require congressional action in a very complex area. Receiver standards have been mentioned as a possible way of allowing higher power emissions in bands adjacent to the GPS spectrum, or at least creating a more predictable regulatory environment for new entrants. I do not believe this will be a useful approach and would suggest instead focusing on defining GPS spectrum protection criteria. It's a subtle difference, but an important one. The creation of government-driven design standards outside of those necessary for national security and public safety can stifle innovation. Receiver standards can also be a subtle regulatory means of sacrificing some categories of users and their applications in rapidly evolving markets. On the other hand, transparent protection for the GPS spectrum environment can provide better predictability for new entrants while not constraining GPS applications. Finally, I would like to mention 2 areas of risk not related to spectrum. In today's fiscal environment, it may be tempting to slow or cancel the acquisition of GPS-3 satellites or hope to rely on foreign systems to fill the gaps. This is a very dangerous idea given our nation's reliance on GPS and the lack of demonstrated reliability of foreign systems. A second risk area would be disruptions to existing GPS users as an unintended result of modernization. There is a need to explicitly confirm that changes to GPS are backwards compatible with the installed base. If not, there could be a transition plan that is developed. There needs to be a transition plan developed with the relevant stakeholders in government, industry, and even non-government organizations such as advisory committees and scientific societies. We have a precious resource in that installed base that needs to be protected. Finally, the spectrum neighborhood in which GPS resides should be preserved, as you've heard from other witnesses. As GPS modernization proceeds, the U.S. government should ensure that the installed base suffers no disruptions as new GPS capabilities come online. And for the aviation community, it is not an overstatement to say that eternal vigilance is, in fact, the price of safety. I thank you for your time, and I'd be happy to answer any questions you might have.
Well, thank you, and thank the entire panel for your contribution. Craig Fuller talked about this simple technology with 1,000 and many more permutations and advantages. I'm thinking in my own area, we have a boat manufacturer now that has a boat hook. It's a GPS. You push a button, and the boat will stay perfectly still without an anchor in the ocean. And of course, John Deere and these people now can apply fertilizers to fields based on the characteristics at that spot on the field, and it has a huge return for the additional investment to make agriculture more productive, less wasteful, and all the rest. And it's all GPS. And this is only the beginning of how we can refine the application of technology for changes in circumstances on practically a 6-inch by 6-inch basis across our country. You've heard the testimony of the previous panel, and I really wonder if particularly Mr. Foley and Mr. Pace would care to comment on it. You have in your prepared remarks, but we've found ourselves in a rather peculiar situation in that I'm sure good-meaning people who see a business opportunity spent some billions of dollars to help achieve a national objective, which is a good one, of making broadband more available, high-speed broadband across our country. And yet we had a GPS system set up and elaborated for a number of years that needed to be in a quiet area, as was testimony before. It was well known. Evidently the price of that spectrum reflected that to some extent. And yet then that spectrum was acquired, and the previous purpose was broadened at the staff level at the FCC, evidently leading people to think they could do something, and it's going to ruin a lot of savings of people who've invested in all this technology. So is this a staff failure, or are people leading someone down the primrose path? Or I mean, or we need clearer fences here, explain to people why this. Evidently, the spectrum price reflected some knowledge at the investor level as to what was going on, but was it in a failure of the technical advisors of these investors? Or do you have any? I guess it's speculation, but looking forward, how can we avoid this waste of resources in the future, or rescue the situation that we find ourselves in? Do either of you have any ideas?
Well, thank you. I think the main thing, and I think we've all kind of highlighted on that, is that we need to make sure that we protect the spectrum that we have. And looking kind of backwards, I think, at least from my perspective as a GPS receiver manufacturer, there are some standards for interference that have been in place for quite some time, back to 1996, I believe. So it was a bit of a surprise for us to see that when this new proposed system came up, it was actually putting out signals far in excess of those receiver or interference protection limits. So any future plans we want to build on those existing limits, and I think that's what the PNT has said and the DOT has said. So to the extent that we do that, I think that's the best way to move forward. And just more generally, as I stated in my testimony, improve coordination between the PNT and the FCC and the rest of the government to make sure that all the stakeholders get represented when new policy decisions are made.
I think, Mr. Chairman, I think looking back at it, I think a fundamental error was in not really applying maybe the intent or the past practices of the Administrative Procedures Act, notices of proposed rulemakings that involve reallocation of spectrum. An argument was made that this was not a reallocation from mobile satellite services to a high-powered broadband terrestrial mobile service, that this was in fact simply a relaxation of some maybe some outdated constraints and some waivers could be applied and maybe some new efficiencies could be found. I think in retrospect that was too clever by half. That it was a reallocation, that a notice of proposed rulemaking should have been done. A notice of proposed rulemaking would have generated the technical data necessary to understand what was involved, and that one would have fairly quickly seen that this was a non-starter. When this originally started back in about 2003, the idea of an ancillary terrestrial component to mobile satellite service was considered a kind of a fill-in, a gap filler, a relatively low-power system. No one was talking about 40,000, high-powered cell towers blanketing the country. Nobody was talking about having an independent terrestrial service separate from the satellite services. The FCC was very clear over the years that they would not allow a separate standalone service, that in fact it always had to be tied to the satellite service and no interference with the satellite service. I mean, these terrestrial broadband systems would interfere with mobile satellite services in their own band, what they call co-channel interference, which is a really big sin. So I think that the position of people at the time was to try to find some way to make these ancillary systems work. I think there was good faith technical effort. There was really no technical data offered, and then people gradually got into trying to change it into something else, a reallocation, and they did not do a notice of proposed rulemaking, and hence I think people were surprised when they found out that when they actually got the data, that it was a much different situation than what they had intended. So I don't know what to say is how do you prevent people from making bad decisions. I don't know that that's really possible. I do think we have rules and procedures that, if followed, would have protected us.
Any other comments?
Mr. Chairman, I just have a quick one. One of the reasons, seriously, for my enthusiasm about the clarity of the Obama administration statement today is that it should send a very clear signal to any agency, even an independent agency. And we really don't have to speculate. There is no one who's done the work, the hard work. There are plenty of people who have issued press releases. There's plenty of representatives making cases. But no one's done the hard work of testing that's come to any other conclusion than this won't work. And so I would hope that the administration, who had to clear the testimony today out of OMB at the Executive Office of the President, I would hope the administration would provide an equally clear message to its appointees in an independent agency to say, if you have some special knowledge that none of us have been able to uncover, then bring it forward. Bring it to the Congress. Bring it to the industry. But so far, we've had press releases, but we've had not nearly the kind of certainty that experts and technical experts in this field have. And I think the process that led to the testimony today is sound and solid and represents the best clear thinking of this administration that the project should not go forward as proposed.
Mr. Cravath?
Thank you, Mr. Chairman. Thank you for the great testimony. There's so much information that you've just given us. I really appreciate it. One of the things you said, Mr. Fuller, I want to make sure that the committee understands it. With a GPS system, there needs to be no terrestrial navigational systems at an airport. So you could be flying, and if you have an emergency, just as you alluded to, you could create an approach to go into an airport, to fly into it that would not have any other navigational devices to it. So if you could expound upon that, that would be very helpful. And also talk about the minimums that you could bring this aircraft down to if you needed to.
You're getting into dangerous ground because I can talk about flying all afternoon. The interesting thing is that, and they'll speak for themselves, but I think this is a topic on which we are in absolute agreement throughout the aviation community. The general aviation community has equipped with GPS avionics for years. The commercial aircraft industry has equipped with this technology for years and is equipping more with the prospect of the next-gen technology being more fully utilized. And all of it gives us the ability, whether I'm in the two-seater Aviat Husky or the Citation jet, or these gentlemen are flying a commercial airline, that we have the technology to take us from the altitude or en route altitude down to a couple of 100 feet above the center line of the runway using nothing but the satellite-based technology above the Earth and the GPS box and the related computers in the aircraft. Furthermore, it allows them to know where I'm at and me to know where they're at, so it provides separation of aircraft, and that's going to be an increasingly important feature with this technology. And it makes it possible to do this whether you're flying to your destination airport that you go to all the time or you have an emergency and you have to suddenly find a suitable runway nearby. So as I said, this basic principle of being able to define precisely where you are in space continuously over time provides all kinds of enhancements. Mr. Chairman, I'm a little slower, so I have a sailboat, but believe it or not, it also helps us. In case the anchor is slipping, an alarm goes off because it shows the boat is moving. So there's all kinds of possibilities.
Thank you. And Captain Cassidy, as a pilot, can you tell me, in regards to next gen and what some of the interference that may occur, what's your nightmare scenario? What do you see that the effects of you flying your commercial aircraft with light squared that could affect you as a pilot navigating down that gulf there?
Well, I suppose a nightmare scenario would be that I anticipated that I was putting myself back up in Juneau, flying down the Gaston Channel, that I had a very highly reliable, highly effective navigation system, and suddenly somebody flipped the switch on it, and then I had to go back to the old procedures. It would make me much more concerned about the safe conduct of flight, because now I'd have a lot less of ability to have a very good estimate at what my arrival fuel would need to be at my missed approach point in order to get to my divert. And that kind of tailors on to what Mr. Fuller just said. I think that one of the big safety aspects of GPS technology is it allows you to be more proactive and anticipate contingency situations further down the road. In this case, I would, based upon what the arrival weather would be, I would estimate what a safe arrival fuel would be that would allow me then to divert and go to an alternate, and also have the coordinates of that alternate, and also on top of that have the approaches built into that alternate in my flight management system. So it's all there, and I have a one-stop shop, and that is an incredible safety benefit that is clearly purely the benefit of satellite-based navigation.
Thank you, Captain. Mr. Chairman, can I have indulgence just a little more time? Thank you. Mr. Foley, in regards to light squared, obviously they're trying to get on the lower end of the spectrum. That's their initial business plan. They're going to try to get into, I see them trying to start working into the higher end of the spectrum as well. Is their current proposal any different than past proposal? And if they do try to get into the higher spectrum, what does that mean to you as your business model?
Well, let me say, I think the light squared proposals have changed numerous times over the past year or so, but primarily operating on that upper 10 megahertz of frequency closest to GPS, all of the testing that's been done so far, all of the analysis has shown that would be just catastrophic. You will have widespread outages of GPS. The majority of the receivers that we tested just did not work at those types of power levels that close. Moving to the lower 10 helped somewhat, but all of the analysis we've done so far says that doesn't get a clean bill of health either. There are still significant problems with that proposal as well. You know, specifically the terrain awareness and warning systems. We talked about ADS-B operations at low altitude. It poses a lot of problems for aviation.
Thank you, sir. And with that, I'll yield back. Thanks for your chair's indulgence.
Thank you. Gentlemen, thank you all for the effort that went into your prepared testimony and for your being here and your enlightening testimony today. And this hearing is adjourned.